All right, hello again. This is Jeff Scott at Blackhawk Technical College. I've been coming at you with the first 17 chapters of iOS 9 App Development Essentials, our book for the 152, 153 Mobile Web Development iOS class for the spring 2016 semester at Blackhawk Technical College. I've done the first 9 chapters, which, as you can see, brings us up to Chapter 10, an overview of Swift functions, methods, and closures. Let me just mention that there's not too much in this chapter on methods, but starting, I believe it's in the next chapter already, in Chapter 11. Chapter 11 is on the basics of object-oriented programming, so we'll talk more about methods a little bit later. All right. So, as you can see here, a function is a named block of code that can be called upon to perform a specific task. What that means is, in an ideal world, a function does one thing, and the name of the function is pretty much synonymous with what the task is that the function is supposed to be performing. All right. They do give a thing in here. I don't know how important you do or don't consider it, but you can see it in blue here on the screen where the author says the terms parameter and argument are often used interchangeably when discussing functions. There is, however, a subtle difference. The values that a function is able to accept when it is called are referred to as parameters, but in the actual function itself, they're typically referred to as arguments. I don't disagree with that at all. So, a method, as they mentioned down halfway down on the page here, is essentially a function that's associated with a class or a structure or an enumeration. So we'll hit on that later on throughout the book. But starting on the bottom of page 75, this basically right here is they're showing the syntax for a function. So when you look at the stuff that's in there, you'll notice that functions in Swift must begin with the keyword func, which notifies the compiler that that's a function. After func comes the name of the function. And as they mention on the top of the next page, it says there, this is the name by which the function will be referenced when it's called from code. Next, inside of parentheses, so all of that goes in here, that's the name of any parameters that might be referenced in code. So you've got a parameter name, followed by a colon, followed by its type. And there can be 0 or more of these. If the function returns anything, you need a minus sign followed by a greater than sign, followed by the actual return type. All right, then the code which is within curly braces. So that's what's mentioned, again, on the bottom of page 75 and going on to page 76. And they give a couple simple examples here. Okay, and the first says, for example, up here, let's see, there's an example that doesn't do much. It's called say hello. And literally it just prints hello down in the console. Notice that there's nothing in the parentheses, which means there are no parameters passed in, and there is no minus followed by a greater than sign afterwards, which means there's nothing returned. Then they give another example, which is a little bit more detailed down below it. Not sure exactly how I got to right here, but in this example, or in the example that we're going to see in just a little bit, in fact, let's look at the example. I've got to go up a little bit here, just a tad. All right, so here's a different example. All right, notice that, again, func, showing it's a function, build message for the name of the function, username, which is the first parameter, and it is a string. It is username, but it'll be referred to in there as name, and it's a string. User count, which will be referred to in here as count, and it's an integer. But the key takeaway here is this, meaning it returns a string. when you call a function, it's pretty simple. Here's an example of a call. Here's an example of a call, etc. So it's the name of the function, then in parentheses, any parameters that you must pass in. In this example, we're passing in John and we're passing in 100. All right, so in other words, John will suffice for the name and 100 will suffice for the count. All right, and in this particular example, like I said, there's really not too much in it. But they do mention that if we want to, we can establish external names for these parameters. There's username, and there's user count, for example. We'll go into this in class. I don't know how important, at least right now, all that is, but we will talk about it. You can declare default function parameters. Now there's a couple rules if you do this. All right. It says Swift provides the ability to designate a default parameter. When you use this, they must be declared at the end of the parameter list so that the compiler does not become confused. So when we call this, if we just pass in the count and we don't pass in a name, the name will automatically be set to customer. Now I'm wondering, and we can look at this. I mean, we can grab this example that's right here. So I can do this. I can grab all that code that you see right there, copy it to the clipboard, and I'm just going to grab it, even though this is in my example that I did before. I'm going to paste this in. Okay? All right. Now I'm going to come in here, and again, I'm just taking code right out of the book, and I'm going to call this, and I would guess it's going to work, but let's just check. And it gave me an error message. Consecutive statements must be separated with that. That's not correct. So this print should be on a line by itself. There. So this should say customer 100. All right, customer, you are customer number 100 from right there. All right. Now, what I don't understand is I thought that since this is a default, that technically this should come after this. So what I'm going to do, and it'll give me an error message, at least at the beginning here, but I'm going to try something. And what I'm going to try is I'm going to try to remove this. I'm going to try to grab all of this right here, copy it to the clipboard, or cut it to the clipboard, then come back in here. Again, I'll have errors for just a minute here. And I'm going to paste this in right there. Then I want to change this around. So in other words, now I've got count first. See, the way I was always taught, I'm just going to grab this and just put in 100 right there and see if this works. And it still said customer, you are customer number 100. See, that's the way I would have done it, because the non, right here, the non-default parameter is the one that I'm passing in first. But it appears as though doing it the other way, this works also. The difference is now, since they're named parameters, I've got the default one before my non-default one. And I was always taught you didn't do it that way. But evidently when you do it like this, it is totally legit to do it in that way. All right, let's talk about some other stuff in here that really becomes important. All right, so I'm going to jump back into the code here. Returning multiple values from a function. A function can return multiple result values by wrapping those results in what's called a tuple variable. So the following function takes as parameters different measurement values in inches. It then converts those values into their equivalent of yards, centimeters, and meters and returns all three. All right, so you see right here for the return type, so what comes after that minus with the greater than sign, in the parens here, that's the return type. So it says we're returning three things. A float for yards, a float for centimeters, and a float for meters. Well, let's grab all of the code that's here, copy it to the clipboard, come back into here. Let's paste this in. Good news to start with. Well, I thought we maybe didn't have any errors. Let's see. Okay, so these should have all been on their own lines. So let that, oopsie. Let that, and return. So I get no errors here. All right, so that's still from the old stuff I've got up above, but that's okay. So I want to come down here and I want to call this. So I want to call size converter. Okay, and I want to pass in that let's just say 100.0. And it worked. So notice what I get. It has these values right here. I haven't done anything with them yet, but I could if I wanted to. So what the author says here is a better way of doing it than the way I just showed you. He shows you this on the bottom of page 78. It says let length tuple equal size converter, and he passes in there 20. All right, and then he says print length tuple dot yards, and it prints down below 0.55556. Print length tuple dot centimeters, and it prints out 50.8, and print length tuple dot meters, and as you can see it prints out 0.508. But the point is we were successfully able to return multiple values. Even though they are multiple values, as far as the system is concerned, they're not multiple values because we're putting them inside of a tuple variable. So that's okay to do. All right, so I'll leave that one here. In fact, you know what I think I'm going to do is I'm going to grab this. Yeah, I'll just leave it here because I've already, yeah, that's fine. So I'm going to go back to all the stuff I've been doing in here. In fact, let's just grab this. I'll do what I said. Let's put a new playground page in here, and we'll call this function examples. Which is fine. And I'm going to remove everything as I always do. I'm going to import UI kit and just paste back in what was there. All right, you already saw that stuff, so. All right, so let me comment this all out. And next we're going to go into, as they mentioned on the bottom of page 78, and going on to the top of page 79, something that's called variadic parameters. And that's when the number of parameters that you have may vary. So I'm going to use their example here, func display strings, and we're going to say strings, string, ... which means we can have different numbers of parameters passed in. All right, so for string in strings, and we're just going to say print string. All right, now right now it's doing nothing because we haven't called it yet, but we're going to call it 3 times. First time we're going to say display strings, whoopsie, and we're only going to pass it in here string 1. All right, then we're going to call it again. You can see the string 1. So we're going to call it again. Oops. And when we call it the second time, let's put in a \n here, or a couple \n's. So let's pass it in string 1, and we'll pass it in string 2. And you can see that they're both in there. Let's call it one more time. Probably guess what's coming. We're going to pass in string 1, string 2, and string 3. All right, and if you notice our output, there's it is with 1 parameter, with 2 parameters, and with 3 parameters. So again, the idea is within the body of the function, the parameters are available in the form of an array object. So this example took as parameters a variable named string values and then just outputted them to the control panel. Pretty simple stuff. All right. All parameters that are accepted by a function are declared constants by default. So if changes need to be made within a function body, you must specifically declare that those parameters are variable parameters. So again, I'm just going to keep coming up and doing the examples that are in the book here, as long as the examples are pretty good, which most of these are, fortunately. Hit enter a few times here, give myself some blank space. All right, so I've got here func calculate area, and we're going to say here var length, which is a float, var width, which is also a float, and we're going to say that this returns a float. something in here it doesn't like, so let's see if we can figure out what that is. Oh, there's two periods there. I guess that's what it was. So, whoops, print, calculate area, 10, 20. Says that I'm missing in here must want the word with. That's what it shows in the book to know which one is which. So all parameters accepted by a function are declared constants by default. This prevents changes being made to the values within the function code. If changes need to be made, those parameters must specifically be declared as being variable. So you'll notice if I come back in here, since I'm changing these, if I remove the word var, I should get error messages now. Left side of mutating operator isn't mutable. Length is a let constant. Okay? And it's back to where it's okay again. All right, so that's a var parameter. When the value assigned to a variable is passed through as an argument, and that function both declares the parameter as a variable and must change its value, and you want that change to be a permanent change, then what you have to do is you have to refer to that value as being what's referred to as an in-out variable. So in order to make any changes to a parameter persist after a function has been returned, the parameter must be said that it's an in-out parameter. So if I come back in here right now, and so let's say I came in here and did this. Var length equal 10. Var width equal 20. Now I think I can come in here now and say length and width. At least that's what I'm going to try to do. Length, width. And that should work. No. Cannot convert type int. Oh, okay, because it's saying that those are floats and it's inferring here. So 0.0, 0.0. So let's go var length colon float and do it here also. All right. Missing argument label with in call. So it still doesn't understand that that's with right there, which is interesting. Var width colon float. Oops. And now it still worked. Okay? And you'll notice that when we came in here, we changed the length and we changed the width. All right, but if I come back out here now and I print length equals width, equals let's see if they have their values of 10 and 20 back again. And they do. So what the author is saying there is if I want to be able to change these and have them be changed permanently, then rather than var right there, I'm going to need to type in out. Now I'm getting a different error. Passing value of type float to an in-out parameter requires explicit, oh, okay, not a problem. So what it says there is when I pass it here, I must use an ampersand. So again, we're getting close here, close to pointers. Can we get rid of this? No, that's my question. Missing argument label with in call. Still doesn't like that. It doesn't like that, so maybe that ampersand must be here. So now if you noticed, I have now changed permanently the length and the width by making those in-out parameters. All right? So next on page 80, functions as parameters. This is kind of cool stuff. You may or may not agree, but I think at least it's pretty cool stuff. All right, so the author says func inches to feet. You pass in a float representing inches, and you return a float, which is going to represent the feet. All right, so there it is. Then, what that code does is it declares a new function named inches to feet. Okay, you can see it right there. It assigns that. Now, what we want to do is we want to assign that function to a variable. So let 2 feet equal inches to feet. I don't want anything after this. So what we've done is we've declared a new function name, inches to feet, and then we assign that function to a constant named to feet. After we've done that, we can now call it using the constant instead of the original function name. And you can see what happened. It might be easier if we put in 100 here. So 100 inches equals 8.33333 feet. Now this doesn't seem, as they mention on the top of page 81, by itself doesn't seem to be that much. We could have called the function by itself. But the possibilities for this, as mentioned there on the top of page 81, become more apparent when you consider that a function assigned to a constant or a variable now has the capabilities of many other data types. In particular, the function can now be passed through as an argument to another function or even returned to another function. So first, as mentioned, I'm going to jump back to the book just for a second. I'm on page 81 here. I think I went up a little too much. All right. So the author says, before we look at what it is, essentially the ability to plug one function into another, it's first necessary to explore the concept of function data types. The data type is dictated by a combination of the parameters the function accepts and the type of result it returns. In the above function, since it accepts a floating point and it returns a floating point, the data type conforms to the following. All right, so there's the parameter that it accepts, and there's the parameter that it returns. In this example, these are the parameters that it accepts, and this is the parameter that it returns. So as the author mentions about halfway down on page 81, in order to accept a function as a parameter, the receiving function must declare the data type of the function as being able to accept that. So as it says, for the purposes of this example, which unfortunately I guess it's down near the bottom, it says we will begin by declaring two unit conversion functions and assigning them to constants. So we've got that inches to feet that you've already seen, that's already there. And we've got another one that's inches to yards. It's on the very bottom of the page, and there's the rest of it there. All right, so let's go back to our code. Let's grab all of this stuff that we've got here. Let's copy it to the clipboard. I'm going to paste it in. Don't worry, we might get an error because it's already been declared, but we'll change that to yards. All right, that should remove any kind of error that we had in there. And the number here must change too then. It's a third of that. 0, 2, 7, 7, 7, 7, 8. All right. So this will be, instead of 2 feet, this will be 2 yards, and that will be set equal inches to yards. Okay, that's pretty much what they show here on the bottom of page 81. So it says the example now needs an additional function, and the purpose of this function is to perform a unit conversion and print the result in the console panel. This function needs to be as general purpose as possible so it can do a wide variety of things. In order to demonstrate this, it says the new function will take as a parameter a function type that will match both inches to feet and inches to yards together with a value to be converted. Okay? We don't need this now. We can get rid of this. Okay? And we're going to write another function. All right, so let's look at this because there's a lot of new stuff in here. All right, what this is saying is I've got a new function. I believe everybody gets this function. We already talked about that one. This is the same, except that the calculation is different because 3 feet in a yard, so this number right here is 1/3 of what that number right there is. That should be 0.02, okay? So we've got our 2 feet and our 2 yards, and then we're creating a generic function here. this function has two parameters. One of them is going to be the function that we pass in. That function that we pass in must have a float passed to it as a parameter, and it must return a float. The other parameter is just a simple float parameter. So if we call this thing now twice, as shown on the top of page 82, so if we do that first one, it's going to convert to yards, and you can see the result. If we do another one, we'll first have our 2 yards print again, then our 2 feet. They also mention underneath this on page 82 that functions can also be returned as a data type simply by declaring the type of the function as the return type. So they give an example down towards the bottom, okay, that's called another function here that's called decide function. Now again, when you're doing this stuff, play computer, especially if this confuses you at all in the least. That's the best thing in the world that you can do to learn this. So if feet return to feet, else return to yards. So again, like I said, play computer here. This is a function. It's called decide function. All right? And what does it have passed into it? It's got a number of feet that are passed into it, and that's of type Boolean. What does it return? It returns an actual function. The function that it returns must have a float passed into it and must return a float, which is exactly what these two things right here are. All right. The last couple pages in this chapter talk about closures, which are an advanced topic in this language. So I'm going to come back up to the top here of the code I just put in, comment all this stuff out as I've been doing. And then let's talk about closures. Closure expressions, it says, are self-contained blocks of code. So it says in the next example that we're going to look at right now, it declares a closure expression and then it's going to assign it to a constant called say hello. And then it'll call it via a constant reference. What? Let's look at it. Let say hello equal print hello. All right, by itself, seems kind of innocuous, like it doesn't do very much. But now let's call it. We should see the word hello. There it is. This is similar to what you do when you declare a function. The difference is the closure expressions don't have a name. Let's take a look at another example, the one given on the bottom of page 82. we did this right, it should show 200. There it is. Now it didn't print out here because we didn't tell it to print out here. All right, we've got a return statement here. So we should be able to print result, and it should give us 200. And there it is. So as mentioned on the top of page 83, again, the syntax is similar to that used for declaring Swift functions, except that closure expressions don't have a name. Also, the parameters and the return type are included in the braces, and the in keyword is used to indicate the start of the closure expression code. A function is simply a named closure. Closure expressions are often used when declaring completion handlers for asynchronous method calls. And they show you an example of that. I'm not going to write that, but they show you an example of it here on page 83 in the text right here. So a closure itself, and on the bottom of the page, they start talking about closures in Swift. And as the author says here, a closure in computer science terminology generally refers to a combination of a self-contained block of code, a function or a closure expression, and one or more variables that exist in that context surrounding it. So they give an example down at the bottom of the page here. All right. And what this says, and I can't make it go up much more because I think what's going to happen is well, there we go. All right. Function A, as it says right there, returns a function named function B. In actual fact, as they mention here on the top of page 84, function A is returning a closure because function B relies on the counter variable declared in function B's local scope. In other words, function B is said to have captured or closed, that's how they get the word closure, the counter variable, and as such is considered a closure in the traditional computer science definition of the word. All right, and that pretty much will finish us up for Chapter 10.